In part one, we took a quick look at this setup. Many an engineer has built a loco or other project with a power source like this. We touched upon engine stalling and some other common problems. We looked at the mismatch between engine and alternator characteristics and saw how the system we've designed is unstable. This is due to the alternator regulator, which in its attempt to control output voltage, ramps up load torque enough to stall our small engine as speed falls. No problem in cars, of course, where the much bigger engine copes easily. Taming our unstable system will develop it into a stable one where the engine only ever revs just sufficiently to provide the power required. We'll get closer to this one step at a time, and the first step we decided was to design a new regulator with a second input, speed.
There is no battery in this engine. There is one wire comes out of it, and that is intended for the on-off switch. Now, unusually, it's off when it's on, if you see what I mean. When the switch is connected down to the chassis, that switches the engine off. When the switch is open, the engine runs. So that makes me ask the rather interesting question, what exactly is it we're shorting down to ground in order to stop the engine? I'm suspecting we might see something quite interesting on this wire if we look at it on the oscilloscope after starting the engine. So makes quite a lot of noise, but that was interesting, the signal we saw there. Quite obviously that wire is the magneto output, which not only is a very useful signal to give us an exact measure of the speed that the engine's going. Looking at the size of it, and I'll work out some figures from what we've just seen on the oscilloscope a bit later, that signal could also be used to switch on or off our external electronics. It might even be enough to power it as well.